Okay, hello again. We are back, and we are talking about plots, more beautiful plots. We are continuing the idea of the morning, and in fact, I want to start with the idea of the last plot that we had. Try to make it multiple plot of this. So we saw this case, and we isolated the COVID cases for Southeast Asia, and for the month of April, just to have an idea. And then we plotted data and new cases, and we use color to separate the country. So, and we finally put lines, okay? So a question that can be valid here is, what can we do to see this in a more clear way? Can we separate? So there is the last component that we can use in our grammar of graphic, is to separate these plots in several facets. Facets like faces, you know, it's like you have an object and you have like the back face and the front face and the side face, the face, different kind of projection in different directions. So here, what I did was, let's see, before and after. So we only added one. Well, I didn't put color. We can put it again, but we add a concept called facet to separate them. And I have to specify two things. One is, what are the variables that need to be used to, that is indicating how to separate things. And second, how many columns? What the hell? 1 second. Okay, so face it. I wanted to do this in the computer, so just let's go one step before, and we are going to copy this thing in the R that we have early. Copy and paste. You can try on your own. In general, my advice, if you have any question, is that you try first. So this is the one that we had in the slides, that you got the countries marked by color. So in the same thing, let's make it just a little narrower here. In the same thing, we are going to change one aspect. It's going to add here facet. There are two option facets. So this is facet, but this is the easy one, facet wrap. And there's a parenthesis here and plus. So facet wrap needs two input. One is, what is the variable that we are going to use? And the way to define the variable, it's a little funny, because there is an old way and a new way. Let me show you how I did in the slide. I say vars. I don't know why we have to say it, but it's the way it is. And this is country. And then number of colors, and col. No, then the way that is the shape of the plot, no? I say 3. And what I did, I put 2 pluses, yeah. There is an extra plus here. It's not very fast, but because I make a lot of computing here. So here, I kept color and faucet, so we have colors everywhere, you see? So let's drop the color to see it simpler. Essentially, we have the information of the country in 2 parts. So let's take color out here. Or maybe we can put color later. Let's see. So if we change number of columns here, you can change this vertical position. No? We can have 4, 1, 2, 3, the way you like. But there is something that is important to notice here. Well, before going to the important, let me just show you something that is not in the slide. And if you look in the internet, you will find that there is a different way of doing the same. Instead of vars country, sometimes people use a formula here. And it's a funny formula because it is nothing before and then tilde and then the variable. Just the way to think it, the way to remember it is think this. Remember that this tilde symbol, you read it like depending. So this literal says separate by facets depending on the country. That is the way that you can read it and remember. It's not necessarily the best, but I prefer, to be honest, I prefer the way I did in the slides, which I put vars. What are the variables that you use for this? But if you Google in the internet, you will find that some people, instead of using vars, they use this formula. Yeah, it's the same thing. It's a different way of writing. In general, the point is that this is a system that has been changing with time. People got a first idea, and with time, people realized that there are better ways to do it. So there is still some dynamic thing, the chain. But I mean, basically what I mean is don't panic. If things don't look exactly as we have here, don't panic. There will be an explanation and you can try. And nothing will break if you try. You should try always. Okay? Okay, the other point that I want to show here is this. You see that all the horizontal lines are at the same time, April, they're only written one time for the 3 or 4 graphics here. And same in the side, you have from 0 to 2000, from 0 to 2000, even when there are very few people. So here we don't see anything because they are relatively big, small numbers. So in other words, everybody is using the same horizontal scale and the same vertical scale. Okay? That doesn't need to be the case. You can have an option in Facet Wrap that is, you have an option that the scales can be free. You can free X, free Y, or free everything. So now you see every graphic has their own Y scale, they all the same, I mean, their own vertical scale. This is 0 to 600, this is 0 to 1, this is 0 all time. This is 500 to 2000, and you see that they are different. So you just compare this slide with the previous slide. Fine.
I kind of missed the encall part. It makes 3 columns out of the all countries, right?
Yeah, yeah. So in fact, you test it. If you have any question, you test it. What happened here if instead of encall 3, we say encall 4? Sometimes it doesn't fit in the screen. Let's see. Here, 4 columns. Okay.
Okay.
And there's another facet grid, but it's probably getting something similar. You can position things a little more carefully, but it's not as important. More important is the idea that are you using the same scale for everybody? The point is this. Here, it's easy to compare. You can see the India is the biggest, and then Bangladesh and Indonesia, and the others are very small compared to that. And that's sometimes the question is you want to say how they compare. And the other time you want to see each one independently. You don't want to compare the number because let's say India is a bigger country, so you will have more cases anyway. So, but you say that the shape of Bangladesh and the shape of India is very similar. The shape of Myanmar, for example, is different. Even Thailand has a completely different shape. And the populations are different, so maybe this plot is more, well, it depends on the story that you want to say. Remember, plots are a tool that you use to tell a story, to tell what you found in the data. We started using the plot, the basic plot command to explore data. And you can explore and you can even make nice plots. But in this course, I am separating 2 tools. One is plot for exploring data for you, and the other is ggplot that you use to present your data to make the paper. Okay. In fact, there are a lot of overlap between two, and you can choose any one of them. But clearly, ggplot is oriented to make it beautiful, and in the other side, plot is faster and allow you to quickly get an idea what is happening. Okay, let's combine now dots and lines. And here I'm going to go to the transistor data. By the way, I uploaded the data. Maybe you can find the transistor data now, the link that I sent you at the beginning of the class. I insist in the word transistor because maybe it's a word that you didn't know. Transistors were invented just after the Second War in 45, 46. And it's one of the most important things that happened in the 20th century. Like everything that we do today, every electronic that we have is based on transistor. Transistor was a big jump between the old electronic. I mean, electronic is from the beginning of the 20th century, but the big change happened when the people invented transistors. It's one of the things that completely changed the face of humanity. And the fact that we are talking now is because you have millions of transistors in your pocket, in your computer and something. We cannot have a computer, we cannot have TV, we cannot have radio, we cannot have, I don't know. Most of the things that we have today cannot be made without transistors. So, and then it's a second stage that they put many transistors in one chip that is called an integrated chip. And that was the technology that essentially developed Silicon Valley. Silicon Valley, the valley where people did integrated chips. The companies that made this were in that valley. So it is something that everybody should know, that transistors exist, that transistors are important. The same way that people should know what is an antibiotic, people should know what is a transistor. Things that are very much in our life today. So in this case, I did something that we did before. I read the data, and you may remember that was an exponential growth. And so therefore, I use logarithm to make the prediction. I model the logarithm. And then when I make the prediction, for the model, I take logarithm. And for the prediction, I take exponent to undo the prediction. That was last class, or even the class before. Okay. The data was not fitting directly. If we take logarithm, it look like a straight line. We model the straight line, and then when we predict, we have to undo the logarithm. And it looks like this. So here I have a basic thing that we had before. You know, we have the data is transistor. Static, we plot data and count. Count is the number of transistors per chip. In this table. By the way, I took the table from Wikipedia. You can check the Wikipedia transistor count or something. And then I draw the points with some alpha, and then over the points, I add a line. Okay. Now, in this case, in the new line, I am changing some of the aesthetic values. They're not the same. Probably data I don't need to change, but instead of, okay, let's do it carefully. Let's do this manually. Okay. Point here is that remember that we have different layers. So we have two layers of geometrical points here. So do I have the data? No, I don't have the data. Do I have the data here? No, I don't have the data. So let's start with the beginning, loading the data with this thing. Okay. I think this will work. Okay, bar. Then let's make it bigger here. And then I say ggplot transistors. And then the aesthetic mapping is X is date, which is a year probably, and then Y is count. And then we add over this geom point. Okay. This is a basic plot. Fine. And you see it's exponential growth. If you want to remember, we can do log here and plot the log of count to see how the semi-log plot look more straight. Yeah, you see more the straight line here. No? Okay, let me clear. I think they will make it a little faster. Then let's plot again count jump point, and then I can also add jump line. I want to put both together, point and line. And what will happen is that the line is connecting the points. No, they have the same x and the same y. So I want to change it a little. I want to say that in the line, I want to say that the y, instead of being the same as the count, I want to make it equal to the predicted. The new column here, predicted. Okay. And they say there is no predicted. So how to solve this? In fact, the problem is that I cannot write y directly here, but I can say that it's part of the aesthetic. I have to wrap it in this aesthetic command. Now it worked. So let's look at the command here. Let's look at what we are saying. We are saying that our data is transistors, and our basic mapping, the initial mapping, is date, and for the horizontal, the date, and the vertical, the count, the number of the result of every experiment. And then we add points. And then we add line. But in the line, I change one of the associations. Instead of associating the vertical position with the count, I associate it with the predicted. This way, I can make it the line more independent of the. So essentially, you can have several data and draw some of them with points and some of them with lines, essentially assigning different mappings, different aesthetic mappings between the data columns and the attributes of the graphic. And finally, we have things like color equal, I don't know, I put it red, I think. And the point, I make it a little transparent. And we got, yeah, that is the plot in the slides, no?
Sir, we kind of get to compare the data with the predicted values, right?
Exactly. That is the idea. In a typical point, the point is this. There are three steps. One is the raw data. You start with the data that you get from your experiment, and you can make a plot of that data. Then you want to see what is the tendency of this data, how they look, what is the kind of the summary, and that is why you make a model. And then finally, you want to compare if the model makes sense, if your prediction makes sense, how it looks, your prediction compared to the real data. You realize that if I did it wrong, if this red line was going like here in the middle, I will be in big trouble. What I'm doing this, what I want to tell with this plot is that my prediction with the red line makes sense. The prediction of the red line, it is really a good, I mean, maybe you don't believe me. You have the right to say this graphic is not very clear. But the purpose of this graphic is showing you the raw data in the points and then the summary of the data in the line giving you kind of the general tendency. Okay, that is the idea. And that is what you see. In fact, to be very honest, there is a tool already for that, probably here. Where did we have it? No. I close it. In the cheat sheet, there is some tool for tendency here. We have it. Let me show it. can make it easier if you want to be lazy. Something here called smooth. You can put a smoothing line to see how the things are going, kind of making a quick projection. And the method is linear model or something like that. You can read them later, and there are many things. But the point is, in the tool, the ggplot can make this line for you. That is good and bad. The good thing is that you can make the graphic very quickly and you can show it very quickly. The bad thing is that, as you remember, we not only want to do the drawing. The model is not only about making a prediction. The model is also about the coefficient. This factor here was important to us. We say exponential of this coefficient, the second coefficient, was 1.4. This means an increase of 40%. You remember that they multiply by 100, and then we take minus 100. How much we increase? We increase 40% every year. This is the other reason why we do the model, to get an idea of the growth rate or the important number that characterize the process that we are looking. For example, if you have plants that are growing or cells that are growing, you want to know what is the growth rate. I mean, the typical question people ask is, what is the growth rate of COVID? Is it increasing or not increasing? What is the R0, R0, the number that people use to project this thing. So models are not only for drawing, but you also want to draw. So how we draw them? This is the way we draw them. We do here. No, where is it? Here. How to draw them? We can add a second layer or more. You can have points and lines and box plot. You can combine all these things together. That's the last powerful idea here, that you can put them one over the other, the layers of this grammar, layered grammar. Okay. Now, in fact, maybe I'm speaking too much, but a very simple idea. In the first part of the class, we show this. What I'm saying is that after you draw points, you can draw other things. And you can draw lines or different lines, and you can have points of different points. You can do, I mean, you have different columns, you can plot different columns. You can plot whatever you like, essentially. Fine?
Fine.
So the point is that you have to decide what you like, and then you have to decide how to do it. For example, you may remember the idea of logarithm scales, and I want to jump to the other example that we had about logarithmic data, the paper by Klaver. I know that you already went and downloaded the paper and read it, so I don't need to repeat it. But this is the raw data, kilograms and kilocalories. We did this plot in the old time. So here I'm taking Klaver, I'm doing ggplot and of the Klaver data, and X is kilogram, Y is kilocalories, and the thing. And it doesn't seem very much a straight line, and they are crowded here. So we say let's take logarithm. And we have log of kilocalories, and they look very much a straight line, and it's beautiful, no? We did this before. But when you see the original paper, there is a little change here, in the sense that here they are not plotting the logarithm, they are plotting the weight, but the scale is logarithm. So here, for example, the vertical, instead of 1, 2, 3, 4, is 1, 10, 100,000, 10,000, 100,000. You see, they are, instead of adding number, they are multiplying numbers. Same in the horizontal. 0, 0, 1, 0, 1, 1, 10, 100, 1,000, 10,000, and so on. Okay? So in this case, the points should be the same, but here we have the logarithm. So in other words, we will like to plot this, but we would like to make the scales to be logarithmic. How we do that? Easy. We have a new piece, scale command. Was part of the grammar. They say that there may be some statistical transformation that we do in between. And one of the transformations that we can do is to change the X scale and the Y scale. They are separated. You can have different options. You can do different things here. And in particular here, I say, okay, the X is a logarithm in base 10. So you go 0, 1, it's 10 to minus 1, 10 to 0, 10 to 1, 10 to 2, 10 to 3. So this plot, the points look like the logarithmic point, but the sides, the numbers are not logarithm, are real numbers, are very clear. So this is kilogram, not log kilograms. So this is 1/10 of a kilo, 1 kilo, 10 kilos, 100 kilos, 1,000 kilos. Okay? And this is the calories. So the minimum will be 1, then 10, 100, 1,000, 10,000. Okay? We get, so, and you can change X and Y. Sometimes, for example, for the transistor, we want to change the vertical and not the horizontal. Sometimes you want to change the horizontal and not the vertical, depending on the problem. So fine, we can make, then I added an extra column with the prediction like we did before. And we can do as before. And there is a little trick that I wanted to show you here. When I draw the X scale, I didn't like, in this plot, I didn't like that it says 1a minus 1. I wanted to have like this. I really wanted to make the same plot. My goal is to make this plot. Hopefully with the same names and the same, hopefully the same font. Try to make this. I didn't finish, but we will see. So we fixed this number, but they are not looking well because instead of 10, they say 1A1. This is written in scientific notation. And I wanted to be written like in real numbers. So I Googled it and I found that there is this option called scales. There is a library called scales, and you can change the way that you choose the labels. So the horizontal scale is logarithmic, and the labels I choose to be numeric with an accuracy of 0.1 or 1 decimal. The rest is the same. The rest, and one, let me show you a tool like this. 0.1, 1, 10, 100, 1000. Okay? How I got this number, I did this option. So scales is another package, different from ggplot, because it can be used in many contexts, and you have to read it. So, but essentially how we do, I probably install it when you look for the thing. So I say scales, this is the package, you click here, and you see that there are many functions here. And you use Google and ask how to draw these things and label, byte, label, comma. You want to show date and you want to show money with a dollar or liras or whatever, percentage, p-value, scientific, different things, different values have different conventions for writing. So you can change that things. It's not essential, of course, but if you really want to control everything, you can control how to show the number. Now, there is something else that some of you may have noticed that I did here. What I did here at the last minute, I stored the plot in a variable. That is something that we cannot do with the traditional plot. The ggplot makes a graphic and you can store that graphic in a variable that you can call later and modify later. So, for example, here, I did all the steps before, but then I put an arrow and I put the result in P. So I stored it and the plot is not shown. Instead of being shown, it's saved in a variable, the same way that we save vectors and data frames and things like that. Fine? Do you follow me in this part? So if in the normal way, the ggplot will be shown. I mean, it's the same like this. Just to say something very obvious. If we do, if I say square root of 9, for example, and I don't say anything, it will be printed. But if I assign the square root of 9 to some number, let's say q, then it doesn't show. So if I don't assign, I see the result. If I assign, I don't see the result, but the result is stored in a variable. Then if I use the name of the variable, I see the content. Or if you want to force me, I can say print, a kind of an order, show the content of Q. It's an order. So the same way that if we use a function and don't assign, we see the result. If we use ggplot, we will see the result. If we assign to a variable, we will not see the result, but then we can ask or we can print that variable, and that printing will give us the plot. Let's do the exercise here. I will take exactly what we had in the slide here. But I need to load the Clever data. Let me see if I can. Can we load the Clever data? Yes, we can, no? Import from text, browse. This is not here. This is in, because this does not depend on the year. So I put directly without the year. This one, open. Clever txt, separated by tab probably. Yeah, separated by tab. Yeah, character, kilogram, and there's a numeric. Perfect, import. Yeah, looks fine. No? Let's close this one, let's close this one. And we do the plot that we were doing here. We take it, we plot, and we store it. So as you see, I did ggplot, but I didn't got anything. Now I can do something else. And then I remember, I have a plot that I want to see. So I say print what is in the variable P where I store the plot. I didn't have it didn't work because I forgot the model. Okay, let's do the model. I forget one part, this one. Can I print P now? No, we have to do again. So I can clear everything, forget everything, and ask for the plot again. I can change many things, or just say P. Remember that if you just use the variable name, it will be printed automatically. Why this is useful? Because I can modify it. Remember that in ggplot we add new layers, so I can add new layers later. I can do this plot and then add more and more things. Let's do that. This is the plot, and I just print it with P. I can replicate it again. And then I want to add a modification. I want to change the colors. For example, instead of having this gray background, I want to have something that looks more like in the paper. I want white background and horizontal lines, so dark lines. There are several ways to try it, and we can try them. Now let's do it in the R. So now that we have P stored, we can play with it. So there is a set of things called theme. Theme, for example, black and white. Show me the same plot, but with a black and white theme. Same data, just a different look. There is another, let's say, dark. What happened? Well, I don't know all of them, but you can play with, like, depending on the mood. Minimal. There are no lines here. Maybe there's a colorful, no? Theme, what the different color, the style that you will like. Set, test, update, void, theme. Gray, maybe. And so on. So you have options. And you can make your own themes. You can download themes. In fact, yeah, there's something that I may send you later. So what we have, gray theme. Okay. So what I was saying that since I already saved in P all the data and all the aesthetic, everything, I don't need to say it again. So the point is, if you want to experiment, it's very easy. Like, you start with the ggplot and the basic plot, and you store it. And then you start adding more options to see if you can change the color. If you want to experiment, you can you save the part that you already like, you save in a variable, and the part that you are testing, you try one by one, and then you keep, like, building one by one. We can try to do something like that. Okay, one more point here, the graphical thing here. So we have, I choose theme line draw, and then you can add labels. For example, there is a command labs. It's not laboratory, it's labels. And essentially you can put different, you see there are many options, but here in particular, I choose the horizontal label, the X label, and the Y label to be like in the original paper. Okay, this I took from the original paper. Shall I show you the original paper? This one. Body weight, kilos, heat production per day, kilocalories. So I want to have a white background and dark lines, and maybe a kind of calligraphy font. So what I managed to do at this level, I managed to make it white and black, no gray, and with black lines. And I managed to put the number here that look like in the paper, and I put the title here. Okay, that is what I was able to do yesterday. What I did not manage to do was this point. I didn't manage to change the font. And the reason is because it requires more time, and I didn't want to spend too much time in that. But if you want to change the font, you can change the font. What I did instead was I changed the color. And that is probably the most complicated part, that you have your own theme, and in your own theme, you change the axis titles, and you have to use some command like this element text, and here you can say color or font or something like that. Honestly, I don't recommend you to do this, but if you want to do, you can do it. I don't recommend that you spend too much time changing colors and so on. Like the defaults, 95% of time are fine. Probably 99% of time are fine. They are beautiful. They are publication quality, and you are fine. So, but I wanted to show you that you can. In summary, the point is this: you have a tool that you can easily get something nice. And with some effort, you can make it as you want it. You can really modify everything. You can change the fonts, and they're nice things that you can see later. In fact, I can send you some link. These are the tools that are used in the newspapers to make graphics. You know, if you see the, I don't know, the BBC and New York Times and people, they are using this tool to make their plots. Well, these are some exercises that I was proposing. Maybe we can make a homework. I will not do it right now, but just to think, when you download the slide, you can try if they are not in the homework. Any question about this thing? These are really kind of artistic questions, okay? Not very much about, you see the science doesn't change here. It's just more like an aesthetic. And truth is, in most cases, the journal that you are publishing will put you the rules. No, if you are doing a poster for a conference or your final project, you may want to control your colors and do things like this. Eventually. Now, you want to publish this. This is going to publish. And there is a point that you need to know. And maybe you know. So let me show you and you tell me how much you know. If you take a picture with your camera, most of the time you get a JPEG. This is the kind of file that you get with a camera. Like you get music with MP3 and video with MP4. When you take a picture, you get JPEG most of the time. When we do graphic with Markdown, normally we got a PNG file. But if you write in a paper, you want to use something else that is called PDF or SVG. There are two different, depending on the journal, that some take PDF, some take SVG. Do you know the difference between all these systems, all these formats? They are completely different. The JPEG, PNG, and PDF are completely different. What can you tell me about them? What can you tell me? You can say Bilmiorum. I don't know is always a valid question, a valid answer. It's always valid to say I don't know. And it's probably better to say I don't know instead of saying something that you don't know and try to invent something. So, do you know? Do you not know?
I know.
Huh? You?
I know, but not everything.
Well, but you can say something. You don't need to know everything.
I know that the GPG is large file because it's like photograph. PDF is like text but not text file. It's SVG is for the not data, but I don't know much about SVG. I know PDF and PNG and GPG, but I didn't heard SVG.
Okay. There is a basic distinction that people should know. There are two ways to represent graphics in a computer. One is what we call a bitmap, or if you like a pixmap, in which you take your picture and you decompose the picture in small picture elements. Did we talk? Maybe at the beginning of the class we say that we have this picture element and we have 1 byte representing the grade level, or 3 bytes representing colors. That is a basic idea beyond PNG, JPEG, TIFF, GIF. They are all based on the idea that you decompose the image in many small picture elements. And in fact, when you buy a camera, they say this is 24 megapixels. What are the mega millions of pixels? What are the pixels? The picture element, the point that you get. So if you have more pixels, you probably have smaller pixels and you can see more finely. But at the end, you have a discrete thing. You have a point here and then a point on the side, and they are disconnected. You have a kind of a grid of points. PDF, on the other side, is a completely different idea, and SVG has the same philosophy. They are not point by point, they are a mathematical description of the object that you get. For example, they call a vector description. You have a starting point and an ending point, and you draw the line following a mathematical formula. So let me give you a visualization here. I have the visualization here. I took one of our data and I make the plot in PNG. Okay. So if I zoom it, as I hope you can see it, and you zoom, you will see the pixels. You see here, no? If no, let me make it even bigger.
Yes, we can see.
We can see.
Okay, good. So you have to decide what are the pixels. So in fact, if you feel kind of disappointed, these numbers are not real numbers, they're just a lot of points. The borders are not really border, right? In normal resolution, you don't notice them, but they are lying to you. They are not real. So yeah, if you look from distance, you don't see the difference. But if you zoom, you see the point. You see the pixel. So you have to decide how many pixels you want. On the other side, if you have a PDF, this is the same plot in PDF, and then you zoom, and then you zoom. You have the information that there is a point here and there is a radius here, so you have a mathematical description of this object, and it will be infinite resolution. You can zoom. Well, the computer has a limit, but the description of the file is infinite resolution. You can zoom forever. Let me show you the number, for example, here, this 160. You see? I got the limit of the zoom of this computer, but if I keep zooming, it will be always soft, never broken. That is the main difference between the two ways of representing image. Vectorial is this description, a mathematical description that has infinite resolution, and it is the thing that you really want to print in a book. When you make the paper, you do PDF. Now, on the other side, PDF and these vectorial things tend to be slow. They take too much time. And there is another point that if you have PNG, something like this, and you do one plot or 1 point or 1 million points, you have the number of points will not change the size of the file. Okay, you still have the same. But in a PDF, you get more points, the file gets bigger because you have to describe more and more points. So in other words, if you are doing a presentation like a class, you do, well, depends on the case. I normally do my plot with SVG. If you zoom in my presentation, you normally got SVG. But in this case, by default, you have PNG. What do we have here? No, we don't have a very clear plot here. Anyway, there is another point, but I will not enter in detail here, that PNG and JPEG are bitmap. but they are also oriented based on different ideas. JPEG is designed to handle pictures that you take with your camera, in which the colors change slowly. For example, here you go from this side, the color change, but not very dramatically. They change softly. In a typical plot, we have a different situation. We have black and white immediately. You have black and white, and there is nothing in between. JPEG is not good for that. Maybe we will make an experiment in a minute, okay? When we get to this, I will show you an experiment. So, in other words, if you are going to print the paper, try to make PDF or SVG. If you are going to present in a slide, do PNG. Try to have high resolution anyway, but do PNG. If you are managing a picture, like a photo, use JPEG. If it's not a photo, don't use JPEG. How you choose this? Well, we have two options. One is when you write your Markdown document, you remember that we have this chunk, and there is some option that you can put here, like message, true, false. There is an option called device. And here you can say what is the way that you want to plot it. So for example, if I'm going to do this plot, we can try. Well, let's see if we have time later. We try this one. So if we have a plot, we can decide in each chunk which format we use. Yeah, maybe we should do it right now. Okay, let's make a quick thing. So I'm going to make a new Markdown that are going to be empty. And I am going to start with, okay, class 27, date 11, 2021. That will be enough. Let's see the history. So we start, this is the student data or what? Let me find where we load the student data. I don't want to repeat myself, so I want to, here, library reader. Okay, so let's start from insert a chunk, and here I'm putting library reader student until here to source. Okay, I recover it. Maybe it will be nicer if I do something like put this in a different column. Column type, column sex is a factor, and handness is another factor. An option that are given by the system, so no big deal. Okay, we read the data, and then we want to plot. I'm doing here typical R library. Let's put library here. The other library that we use, library dplyr, and library what is the library? Is ggplot. That one. ggplot. So, and now we can do the thing that I was doing in the class. This one, ggplot student. Let's do the basic thing. No, it's a basic plot. And we can ignite this one. I need a name. I will put it practice class 27. Let's see what happened. Will be shown here, I hope. Okay. Okay, we can make some change here. For example, I don't want to see the warning or I don't want to see the message. I don't want to see the warning. And I want to say what else? We have nothing else. I want to hide this thing. I want to show output only. I don't echo false. I don't want to show the. Okay, let's put it. Let's keep it. Why not? For the class is fine. I'm just throwing this error here. Okay. Same the one in here, and this is the plot. Now, let's see this. I am going to open this in the browser. And I want to see what this is. I'm going to here is the browser, and here is the picture. I'm going to say open image in new tab, and I see that the image that we got is called, what is this? Zoom. Yeah, I can see the pixel here, no? It's a PNG. I can see here PNG. In fact, there is an option that will make it easier here. Let's do it again. There is a couple of things. One is like we go to options here, output option. There is an option that is called figures, advanced standalone. I don't want it to be standalone. That is the point. That will make the figures to be separated and make it easy to understand what is happening here. Let's do. So we are making the plot again, and there will be less errors. And I'm fine. Blah 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 blah. Let's see the browser update here. Okay, the error disappeared. We have the ggplot, and here we can open a new tab, and now it's better. You see, this is the picture that I made, and if you see, it is called PNG, and name is chunk PNG. We can put a name here. Let's put a name. I will put a name in the figure. How we do that? Here we put the name of the chunk. This is kind of plot 1. Okay. And I want to make another call. I will do it again. And this called plot 2. They have to have different names. And here I'm going to say device SVG. Sometimes the SVG doesn't work depending on how you got your R. Be sure that you use the official R. I had problem in my case. I needed to update my R to get the SVG working because the one that I had was not including. Okay, if everything goes right, let's see what we got here. We got updating here. So this is the figure 1 and the figure 2. They look very much the same. Maybe the little change, if you are careful, you will see. And the main difference is that when I say open a new tab, the first is plot 1 PNG. You see, I choose the name. And in the second, I choose open image in new tab. And this is plot 2 PNG. Ah, my gosh, I did something wrong. I got a PNG instead of a... it didn't work as I expected. What I did wrong? Device equals VG. Okay, I have to check this one. So let's do something. Since it is late, I don't want to spend your time trying to find the thing. So let's move and let's see the next step. Maybe the command is not exactly device. I have to check it. Maybe it's graphic device or something. I will come back to that in 1 minute, okay? In the meantime, let's go back to the slides and see what are the options that we have here. Not device. So let's see. There is another option. You can save the plot manually with the command ggsave. And in ggsave, you have to say the file name, and you can say what is the plot that you stored before, and what is the device. Device can be PDF, TIFF, JPEG, PNG, whatever you like. And then you can tell what is the size, the width and the height of the picture. So the only one that you have to say is the file name. So let's do this. So here, let's go back to the R. And we have this P. We say that we have P, it's a graphical thing, no? And we want to save this P. So I will say ggsave, and I will say file name. This is plot1. No, name. Output1.png. And I will say that the object that I want to save is, what are the options here? The plot that I want to do is P, the object that we saved already. And the device is PNG. And now I want to do it again, but this time I want to do PDF. Output 2, PDF. Now I can see I have up to 1 PNG, up to 2 PDF. Let me see if I can open. No, here what I open, a folder in a window. Here. Put 1 PNG. We open it. It's this one. And you can zoom, and you can see the pixels. The trick is that this PNG, you can take it and put in your PowerPoint, and you can put in your Word file or whatever. Output 2 is the PDF. And here you see infinite resolution. So yeah, this is working. The only problem I have to fix here, why it's not working. We will see, we will see. Here. So you have two options. One is to define the format in your Markdown file, and the other is to do it manually. If you want to know more, you have to do help. Now, what are the alternatives to get help? First, you have to know this. You have to, every command that you want to know, you can say help. You write help here in the help slide, and you get it here. Second alternative that you have to get help is to, well, you have all these sheets. These are the description, and in this page there are many, much more than we will like to know. There are too many options. And in particular, the one that I was showing you is this one. This is the one that we are using today. Okay. And the other option is the vignette. We already spoke about this. You can use this command to get examples. Okay. So in general, my point is this. If you have any package that you want to know, you go to package, you see what is the package name, you click in the package name, and you see what are the functions. If you are lucky, sometimes beyond description, here you have only description, not very good. But if instead of description, you get something they call vignette, like let's say, for example, I don't know. We know that ggplot package, you click here and you see that there is a user guide, and you click here, and here you have external help, extra help. Many packages have vignettes. So you have to look for that. That is the keyword that I want to give you today, vignette. It's a kind of help. Okay?
Okay.
So, and that is the last slide that I have today, but I think I owe you the question. Let me see what I did in my classes. I did, when I plot things, it's not the devices, it's dev. It is, okay, this is my error. This is not called device, it's called dev. I'll do again. So after this, you should be able to draw whatever you like. This we got it, this we got it, this we got it. Yeah, class 27, then we open in the browser. And here we are saying this is the first image is a PNG and the second image is SVG. Okay. So, in other words, you can chunk by chunk decide which one are going to be. This didn't grow so much. Which are going to be text and which are going to be vector, which are going to be pixel or bitmap based, and which are going to be vector. Let's see again here. By the way, yeah, good time to write your student number again. Let me zoom here. This is the PNG. If you zoom big enough, you will see the pixels. And if in this one, this is the SVG. And if we zoom, no, not the zoom, the other one, this one. You see that they never lose definition, they never got pixelated. So I personally like SVG very much. They are always look quality, but sometimes they take too much time. Sometimes if you have many points, then it takes too much time. And in that case, I prefer, okay, we got the, in that case, I prefer the normal option, the PNG. Now, the last comment that I owe you is this. If you got, okay, not this one. Let's close this one. Let's close this one. If you want to change the options for everyone, I mean, well, let's say this. You can change the device chunk by chunk, one by one. But if you don't want to do, if you want to set the default, you can omit here, and you go here in the at the beginning of the document. Let me put it here, it will be nicer. And here you have this option. You say knitter, the library knitter, and you say options of every chunk, the default of every chunk, and you $set. This syntax is very crazy, but I just copy and paste, and then I put here the SVG. So essentially, at the beginning of your file, you can use this command to set the default for every block. So I'm compiling here, but let me show you, I put it in the slide. In the meantime, I show you my slides. It is in the slide. Here. So it's not device, it's dev. So let me fix that thing in the class 27. It's not device, it's dev. which of course is an abbreviation of device. So in a minute, this will be ready. So here, now what I did, I changed the device to be SVG. The default device is SVG. Now, if I open this image, I will see that it's an SVG, automatically become SVG. So here you set the default, and then you can do chunk by chunk. Okay. Okay, I know that there's a lot of content, and I know that it's late, and we are all kind of, I need coffee. We are low in caffeine, but I try to say everything in this class because it's the last one class, and we still have the next class. I hope to mix everything together. Like we know how to read data, we know how to make model, and we know how to plot. There are a couple of models that I still want to see next class. But yeah, that is the idea. If you have any question, now is the time to ask. If not, it's not the time. Yeah, Dev. No questions? Too many questions. We can. I want to do a test. Okay, you will hate me, but I want to make a test here. I want to make this was SVG here. But if we have 10 seconds, I want to take JPEG. I don't know if this works. Let's see. Let's see what happens here. Or maybe the plots. No, maybe we'll do the other way. Okay, stop. I don't care. No, here. Let's do. Easier here. We did the saving. We save PNG, PDF. What if we do JPEG? Okay, working. So this worked well. And here we have the third option. Okay, up to JPEG. And get it. So let's see if we see the problem here. We are going to zoom. It's very subtle. You will not see it in the screen, but if you zoom very, very much, and sometimes the resolution is lower, you see. But if you zoom very much, you will see when you have JPEG, you have here some colors that don't match. There's some blocks here you will not see in the screen. But I will do something. I will give you the commands to make your own thing. And if you will see that if you zoom a lot in the JPEG, you will see that when you zoom, they tend to kind of spread the content to the side. The story is this. We have three basic options: PDF, something vectorial, PNG, something pixmap, and JPEG. JPEG, in this case, is the worst. Okay, JPEG is, for this kind of picture, is the worst because you get a lot of irregularities, a lot of bad pictures. I will show you, maybe I will prepare something better for next class. If you are not showing a picture that you take with your camera, a photo, if it's not a photo, don't use JPEG. JPEG is for photos. It's very good for photos, but only for photos. For anything else that you create in the computer, try to use PNG, TIFF, PDF, something like that. Okay?